Good evening, everyone. I am Sir Gypsy B. Corpus from San Josep National High School, and welcome to Tele-Turuan Season 10, Module 2 in Grade 9 Science. Energy is the ability to do work. Everything exists or ceases to exist because of its presence or absence. It is stored in different forms and can transfer and/or transform. It can be transferred without being transformed. It can also be transformed without being transferred. It can also be transformed during transfers. In general, the energy acquired by objects upon which work is done is known as mechanical energy. Potential energy is the energy in matter due to arrangements of its parts, its composition, its location, and structure. It is commonly considered as a stored energy having the potential to do mechanical work. The various forms of potential energy are gravitational, chemical, elastic, electrical, and nuclear. Kinetic energy, on the other hand, is the energy in moving matter and wave. Some forms of kinetic energy are motion, radiant, sound, thermal, and wave. Chemical, electrical, and nuclear energies in general exhibit characteristics that are electromagnetic in nature, though they also have potential energy. Recall in grade 8 science that mechanical work done when equated to changes in the mechanical energies resulted to operational definitions of kinetic energy in the following equations. For potential energy, the general equation is PE is equals to mgh, where PE is gravitational potential energy, m is mass of objects, g is acceleration due to gravity, which is equal to 9.8 meter per second squared, and h is equals to the height of elevation difference. While kinetic energy has a general equation of 1/2 mv squared, where Ke is the kinetic energy, m is the mass of the object, and v is the velocity of object. All moving things have kinetic energy. It is energy possessed by an object due to its motion or movement. This include very large things like planets and very small ones like atoms. The heavier a thing is, and the faster it moves, the more kinetic energy it has. To calculate velocity or speed, the equation from the general equation of kinetic energy is V is equal to the square of 2 multiplied by the value of the kinetic energy divided by the given mass. And to compute for mass, the formula is M is equal to kinetic energy divided by 1/2 of the square of its velocity. Let us solve some problems involving kinetic energy. Problem number 1. Calculate the kinetic energy of a 1,000 kilogram car traveling at 60 meters per second. Using the formula Ke is equals to 1/2 mv squared, you will get an answer of 1,800,000 joules. Remember, the unit of energy or energy is expressed in joules. Problem number 2. Determine the kinetic energy of a 625 kilogram roller coaster car that is moving with a speed of 18.3 meter per second. With a given mass and a given velocity, you may come up with an answer of 104,653.125 joules. Now let us have problem number 3. Missy D. Water, the former platform diver for the Ringling Brothers Circus, had a kinetic energy of 12,000 joules just prior to hitting the bucket of water. If Missy's mass is 40 kg, then what is her speed? Remembering the formula in computing for the velocity using the general equation of kinetic energy as Ke is equals to 1/2 mv squared, we can derive the formula P is equals to the square root of 2 multiplied by the value of kinetic energy divided by the given mass. And the answer for problem number 3 is 24.49 meter per second. Let us pause for some reminders from our sponsors.